So here's my question, and we might as well have this on the video. Here's my question about daylight savings time. If it starts at 2 o'clock a.m., because they actually tell us daylight savings time is at 2 a.m.
It's 2 p.m.
No, it's not p.m., it's a.m. It's in the morning, it's in the middle of the night.
2 a.m.
So does that mean it happens at 2 a.m. on, like, if my watch was set to Saturday's time? Or does it wait until 2 a.m. according to Sunday's time? And if it waits, then how do we ever actually get there? Because we'll actually get to we'd get to 3 o'clock Saturday time, and then it would be 2 o'clock Sunday time. You see what I mean? This is why they did it in the middle of the night.
Do you know what it means?
If it happened during the day, there would be an hour of confusion. If daylight savings time happened during the day, there'd be an hour of confusion. Because it's when do I change my clock? Do I change it at 2 o'clock, like via Saturday time? Or do I wait until 3 o'clock and then make it 2 o'clock?
Yes.
I don't know. So today we need to wrap up 3.3. 3.4 is going to be an exemplary option that we will come back to. I don't want anyone to mess with 3.4 right now, so I like there's maybe a set of notes in the folder, but there's nothing else because I don't want you guys doing anything else. We're gonna do 3.5 and potentially 3.6. Oh, I thought you needed help. I saw the struggle. And they are the same sort of work. So it is one combined assignment on Schoology. It should already be active. If it's not, let me know and I'll just click the button. But it should already be active. I'll try to check during my planning period. So we ended on whatever day we last met, Friday, talking about Alex and Mia. Now, how much interest had Alex earned? Monica?
78.67.
78.67. And Mia had earned
50.
50 bucks. So now it says after 16 months, does Mia still have a higher balance? So be careful here. If we're looking for balance, well, remember, we then calculate over here that my balance was actually, how do I find balance? And what does balance really mean? Sam?
So balance is your principal plus your interest.
Balance is principal plus interest earned. So up here for Mia, her balance was $3,050. And Alex's balance was $3,028.67.
Yep. That's not
So now we have to do this after 16 months. So to do that, what's the tricky part about 16 months? Huh. There was Sam's card. Anish, what's tricky about there you are. What's tricky about 16 months?
It's not a year, you have to convert to a decimal.
Yeah, how do I convert? The biggest thing we have to convert to is years. It could still be a fraction. It could be like a mixed number. How do I convert months to years?
You divide by 12.
We divide by 12. So I'm actually going to scoot these up, and since you guys can't scoot things on your paper, you can do your work wherever you want. But I'm going to make our new interest for after 16 months. Can anyone figure out another way that we could do this? Dom? Simple interest. We like it because it's simple. The same thing will continue to happen over and over again. So if we knew how much they made in 8 months, Anish is right. We could convert 16 months to years, do the math over again. Or, since my time, what has happened to your time?
Double.
It's doubled, so my new interest amount will just be double my old interest. So I got to double my $78.67. Can I get somebody to do that, please? And, oh man, this is really tough. I got to double $50.
13.
So Mia's is easy.
Alex is $157.34. Yeah.
So now let's talk about balances. Alex's balance. Notice that I'm color coding everything. I was waiting for that to happen. No, you're fine. I was quite surprised that these were standing here as well as they were. So in that case, I always say gravity works.
Gravity works.
We'll leave that on the floor.
Separate them on the so one is outside.
Jeremiah, home.
Okay.
How do I find Alex's balance?
Alex's balance. So you know what you have after 8 months, I think, right? Do we know
Well,
that?
now we know 16 also. Now my 16 months, I doubled my 8. Here's my
Yeah,
interest from
and
16.
You would add the balance you had after 8 months with the amount of interest you earned for 16 months.
So wait, I earned interest for that first 8 months, and then I earned 16 more months of interest?
No. So he had 3,028. Wait, no. How much money did? Okay, he had $2,950. Then after 8 months, he earned 4%.
Do we care about 8 months now, though?
Nope.
So forget about your 8 months.
Okay.
But you're making this more complicated than it needs to be.
Okay, it's 2 times as much it's 2 times the amount of interest he had.
So make this as easy as possible. How do I find his current balance right now?
Just add the amount of interest you had after 16 months to his balance.
To his what?
Balance.
To his...
Balance.
We're looking for balance. Noah?
Principal.
We want to add it to the principal. So take the amount he made. This 157.34 is the total made. We cannot combine these. That you were like about to combine these amounts. This is total interest earned. So now ignore the 8 months. This is now our interest earned for after 16. We add that to the initial 2,950, and Alex's balance is now 3,000.
107.
Thank you, $107.34. We excuse me. Do the same thing for Mia, except she started with 3,000. She earned 100. So wait. How's Alex have more money now? He started with less. Alex started with less money, now he's got more. Ozzy?
He has a better percent rate, so it eventually catches up.
Please make a note that Alex's rate is better. So once he has more money, he will now always have more money unless one of them do something to their account. So if we were to like graph this, Mia is consistently increasing. Alex starts below Mia, but he's increasing faster. So now that he's past her balance point, he will always be past it because he's actually going to keep getting more and more and more beyond her. So their difference will keep getting larger as time goes on. Yeah.
What if Mia were to add money to her account to make her
It depends if they would let you do that. So if this was like a CD compared to if it was just a bank account, if it was just a bank account, you could keep adding money into the principal. But if your rate stays the same, still Alex has a better rate. So it depends on like, she could add more and get above Alex, but then if she leaves it, he'll still surpass her at some point because his rate's better. So it always comes down to who has the better rate.
Is there any way to change the rate?
You can do what's called refinancing. So I'm debating on doing that with my house. You have to pay to refinance normally, but if you can refinance and get either, in this case, you'd want a better rate. In my case, I'd want a lower rate for like my house. I would refinance my home loan. If I could get a lower rate, then eventually it would save me the money that I spend on refinancing, and then it will continue to save me more money beyond that. So that's the debate of spend money now to save money in the long term.
But is it possible for you for your rate to go up?
If the terms have changed, yeah. So like But then again, remember what we talked about. You could take all your money back and just give it back to the bank. Like, so I could close my account and open a new one if they have a new account with a better interest rate. Always a choice. Suppose your friend has earned $5.51 in 9 months with an interest rate of 3%. How much was his principal? And guys, I have different problems like this on your homework where you're looking for like the purchase price before you, like when you know how much tax there was or things like that. So now we're doing more equation solving work. So this, I can set up my formula, and I don't really have anywhere good to write, so I'm going to come right over here. Interest, P times R times T. Principal times rate times time. We know how much interest here. That was $5.51. We don't know the principal. The rate was 3%. So now, since I don't know the principal, and this is not required, but if you want to make your work look nicer, set up a set of parentheses because my rate and my time, I know both of those things. I'm going to put those together in here. So my rate is 0.03. My time, what would I put in there for my time?
9 divided by, you'd have to do 9 divided by 12.
Or I could simplify it down to,
3.
yeah,
Oh.
3/4, right? 9/12 is the same thing as 3/4.
Or 0.75.
Or 0.75 if you want to convert to a decimal. So, can I do this multiplication?
Yes.
So do it then. So now we have $5.51 equals P times, what did I get from inside that parentheses?
Like 100 thousandths.
What?
So,
0.0225.
I was trying to do it in. Wait,
So yeah, 225
100
ten thousandths is where that would, because tenths, hundredths, thousandths, 10 thousandths. Then to get the principal by itself. Acadia, what would I do to get the principal by itself there?
You would divide 5.51 by the 0.02225.
I agree. More accurately, though, we would say we do it on both sides.
Yeah.
Now, the math that you care about is this, but we also do it over here. So just make sure that you're aware we do it to both sides. Principal amount comes out to be?
$224.45.
What?
I think it was
$245.
$4.
44.
No, it says round to the nearest dollar.
Round to the nearest dollar. Would that round up?
Yep.
Yes.
Yeah, 245. Any questions on how we worked through our equation, how we knew to divide, because this is held together with multiplication? Any questions?
So 5.51 divided by 0.02225 is equivalent to 245?
Mm-hmm. When you divide by a number less than 1,
Yeah.
your value gets bigger. The smaller the denominator is, the bigger your answer becomes. So if you made this 0.0000000000001, you'd get a giant answer.
Really?
Yeah. Because that's like saying I'm going to give $5.51 to every 225 thousandths of a whole. How much would the whole get?
Like a lot.
Well, in this case, 245 would be the whole amount. Any other questions? All right. Any volunteers? We might as well pass out both stacks. Hey, if you want, come over here. Here's 3.5, and there's going to be a ton extra. And here's 3.6. Going to be a ton extra. Because those are all of my copies. What else would I be drinking at this early hour?
Tea.
No, I don't really drink. So my beverage choices really come down to water, juice, coffee, or sometimes almond milk because I can't drink regular milk anymore.
Why not? Are you lactose intolerant?
I have grown lactose intolerant as well. Not So essentially, I was having some issues, went to see my doctor, and he was like, well, let's try to cut out dairy. And I was like, all dairy? And he was like, well, let's try to cut out milk at least. Because I love cheese, like addicted to cheese. I know, so I still eat ice cream. I can still do cheese and stuff. It's just like cow's milk. And this is the weird thing about genetics. We're the only animal species that continues to drink like animal milk beyond childhood. So you need it during childhood to like fortify your bones and help you grow and all that stuff. Beyond childhood, there's no nutritional requirement to drink milk. Like it doesn't really, it's not that it's bad for you, it just doesn't do that much good. So, as a kid, I drank tons of milk. My body essentially took the fact that I drank tons and tons and tons of dairy, and like this is all, I'm not a medical professional, so this is just like what my doctors told me. And now that I've like matured beyond that and whatever, my body's kind of like, you don't need this anymore, stop, like knock it off. So my body gets like upset when I put regular milk into it. So who knows, maybe someday you'll be thinking back and you'll be like, oh, now my stomach hurts, and I remember Mr. Hudson talking about milk making his stomach hurt. But no, my body's basically saying like, I don't need this anymore, quit giving it to me. So if like, yeah. Me? Yeah, I do. Why do you think I don't? My wife's a vegetarian.
It gives you
But you don't need it. I want it.
Oh, yeah, you do need certain things that are in those foods. You can get them in a variety of ways. Instead of eating chicken, I could go eat something else, but I need to take in food to burn calories and things like that. I don't need milk. There's no reason that I need milk. I need vitamin D, and I need those things that I can get from other places. Yeah.
Do you drink like almond milk or soy milk?
Mm-hmm. I like chocolate almond milk. I like chocolate anything.
Yeah.
So in the 8th grade, you are going to have the opportunity to participate. Actually, I think we might give you guys the opportunity this year. We are going to do science fair. And science fair used to be required. Now I think we're just making it optional. And 8th grade, you get like really encouraged to do it. 7th grade, you can if you want to. I don't know how much Mr. Cabilo encourages it. But so you decide to do science fair on what makes a flower grow. And this is a very popular research study that all kinds of people have tried. The Mythbusters have done it. I mean, all kinds of people. So they've done things as far as what if I water or don't water, how much water affects how much it grows. What if I water it with Coca-Cola instead of water? What if I play classical music for the plant? What if I play hardcore heavy metal music for the plant? Well, like, what will these different things do? What if I abuse the plant? Literally, they took one of their plants and they were mean to it. They were like, geez, plant, you suck! And they'd like smack the, like literally they abused the plant. So, if you're curious, go look up the Mythbusters episode where they do this research study. So you know, there's like Adam and Jamie, and so the guy, I forget who's who, the guy without the beard, he's literally just like smacking the plant. It's just really, really funny. But it seriously affects how the plant grows. And what I think they were studying was whether or not plants have feelings. All of this to say, the way we measure these things is a change from a beginning. So I cannot go to Home Depot and buy 10 plants that are all identical size right now. I just doubt that there will be 10 plants of identical size. So I would measure every plant at the beginning and then measure it every time I want to take a checkpoint and see, did I change? Did I increase? Did I change by decrease? What has happened? And what percent of a change is that compared to the initial? So to figure out a percent change, all we have to do is take the amount of the change divided by the original. Is this familiar to anything that we've already done? Like a change amount over a...
The books.
Honestly?
Percent error?
Percent error. This is almost exactly percent error. Difference over original. To find percent decrease, still difference over original. So let's say I'm watering my plant, Miracle-Gro, all kinds of nice stuff. It started at 10 centimeters and it grew 5 centimeters in the week. You're either standing back there, you're not sticking legs through there. It gets too dangerous. So the change that happened be careful. Here's where people make mistakes. The change was only 5. So to do this, and you might on your paper want to write, what we do is the new height minus the old height, and that gets us our change. That gets our 5. It could reduce to a half, and that becomes 50%. So my plant's doing great. It's growing, it's growing. I come back a couple weeks later, and my plant is now 20 centimeters tall. So I'm like, all right, let's change this. Let's see what watering with Coca-Cola does. So I start watering it with Coca-Cola every day. And I come back in a week, and I see that now my plant is right here. Did my plant grow, or it lost, right? So to find that amount of change, now it was at 20 and is now at 15. So now wait, I had 50% and I'm still going to get a positive percent? Percents can't be negative. So instead, we do it in the phrasing. So notice the first one. Hey Jeremiah, can you either teach the class for me or zip it? We both don't need to be teaching at the same time. So if you know what I'm going to teach, come on up here. Otherwise, zip it. Cool? Thanks. Please underline over here that was increased by 50%. And then over here, we would just say decreased by 50%. We are not using negative numbers here. People will try to say, well, the amount it changed was a negative 5. No, it went down by 5. It was a change of 5.
Just like distance.
Yeah, exactly. Just like distance. So, in general, the equation for percent change is just change over original. And then, of course, multiplied by your 100. In general, it's just your change amount divided by where it was that we started over 100. Or, sorry, times 100.
Why times 100?
To get it to percent form. Because this, remember, spits out our decimal form. This division would just give us the rate, like 0.87 or whatever. Then we'd have to get it to percent form, which is the times 100. So let's say that Mr. Smith is having you guys do some push-up challenges in gym.
Yay.
And in the first month, you did 15 push-ups. The second month, you come back and you're like, all right, coach, I can do more. I got this. And you do 30 push-ups. What, Whitney, is the change in that situation for push-ups? 15, right? So if I start setting up this percent equation for percent change, and actually, am I going to have a percent increase or a percent decrease? Increase. So I might as well just go ahead and say percent increase is going to be my change of 15 over what had I done originally?
15.
Now wait a minute. What happens if I have 15 over 15? I get 1, and that's really then 100%, which really means that you did what?
Double.
You doubled. A 100% increase means that you doubled. Because I went up by as much as what I had done originally. So be careful when we're talking about comparison percentages, because I did 200% of my original. I increased by 100%. Monica?
Can I show how to do the punches?
Sure. Are you trying to come up here?
No.
Okay. Well, then you mean talk me through? Is that what you're asking?
Yeah.
Okay. Walk me through it.
Okay. So here you did 100 crunches and then you did 114. So your change would be 14 and that over 100. So basically that's already, the 14 would be the percent because that's in percent form over 100.
Boom. Whenever I have 100 as my denominator, My numerator is my percent. We had a 14% increase. Try the got it when a frog jumps. We measured its body sitting still on the table. It was 51 millimeters. 51 centimeters would be a crazy large frog. 51 millimeters end to end. It jumps. We're recording slow motion or something like that. And we see that it is now 89 millimeters end to end. What is the percent increase in body length? Try this on your own. You may chat with a friend near you to help you. So when it doesn't say, I normally, once you're at your answer stage, go 2 decimal places. So hundredths place, but of percent form. Because if I just say hundredths place, you might round it at the decimal and then convert, and then you're losing all that detail.
Wait, what do we round it till? I wasn't.
After you get it to percent form, round it to the hundredths place.
Okay, cool.
Oh, yeah. Do you know where Mr. Combs' room is? So it's straight. It's down the science hallway.
There's like a hidden room.
Yeah, it was right. Somebody did get lost. I was right.
It was Izzy.
What, Jaslyn, is the amount of change in this situation?
The amount of change, it's 38.
38. And our original that we plug in, Julian, what was our original here? 51. So when we do that division, do you have my percent for me, Julian? 74.5. 0.51. Can I get a verification?
Yep.
Verify.
Sweet.
I verify.
Any questions on how we did this?
I stand.
Our change, we just always do the subtraction to find the difference, divide by the actual or the original. So, what's really interesting about our space travel is the only, half of the values that you know, and half is a very general term. A lot of what we know and what we accept and things like that are only because we exist on Earth. So if we were to go to the moon, which many people have been, there's footprints up there. My brother is a big nerd just like myself, but he's 6 years older than me. He has a telescope, a pretty decent one, and you can get with a good telescope, you can see actually trash that was left on the moon. Essentially, there are certain things that they left up there to prove that we were there. So all that conspiracy theory where people are like, oh, it was done in a warehouse. Yeah, no, we were there. There's proof. And they literally did. Well, so debris is a more scientific word, but one of the things they left up there is a mirror that you can, at a strategic time, shoot a laser up at the moon and it will bounce back.
Whoa.
And if it was only the moon's surface, it would absorb the laser light. It has nothing reflective. We left it there. That's another way that you can prove that we went to the moon. So if you went to the moon, let's say that on Earth you weigh 154 pounds. I wish I still weighed that much. On the moon, you'd only weigh 25.5 pounds. Because mass is preserved. Weight is relative. Mass is preserved. Weight is relative to gravity. So, what would be our percent decrease of weight on Earth compared to weight on the moon? So what would be your percent decrease here?
Bless you. Thank you.
Try this out on your own. Take a second to solve this math. Later. like lunch, that's a great time to tell nerdy jokes.
Okay.
What's nice about percent change too is I can always set up my numerator big minus small. The date, the 7th, it's also up on the assignment board, and it's also always up on my start slide.
Cool.
Mr. Hoover. So it's easy to do our change because big minus small. Our change here comes out to be
Turns out to be.
What?
I had it.
That's a big change.
So did you write it
Yes.
down?
No, I didn't. But
So if you calculate it, you should write it down.
100,
Do not let your calculator do all of this for you. So you get
28.5.
28.5. Now the original here, what are we using as our original? Andrew's still looking at you if you want.
Original is 145 pounds.
Careful. 154.
154. That's my original.
So be careful at what direction your change is going. We started on Earth, went to the moon. So we're decreasing, bless you, our original is 154. When I do this math, my percent decrease, Ashley, do you have this calculated?
84%.
Verification?
Yeah.
Sweet. And then question? Any questions up to this point?
Wait.
Dom.
This is about the percent sign. Does it have to be like
Open circles?
from like left to right, or can you just put it from like starting at the right time?
So on all of those things, I default to what has the system told us. The percent sign on a keyboard, or are you not going to give me?
I don't think they have a percent. Yeah,
Oh, well, there is on a keyboard. It always goes, if you were to reference, well, I can't, my chords are too wrapped up. It always goes top right to bottom left. And in coding, like when you type code for a computer, this slash versus that slash mean two very different things. So I would always, if you're making a percent sign, go right to left, top to bottom, like that.
What is the other slash?
It's just different commands, like what it's telling the computer to do. I'm not 100% certain. The furthest I went into coding was LaTeX, like how to type math code. So like you would type, like command prompt sort of stuff, where if I want the division sign, I would type like /div or things like that. Like /mult would be like multiplication sign, or those sort of weird things. Yeah.
You see that Khan Academy lesson thing for it?
Yeah, they have Code
I
Academy.
did that for a while. It was
That was in college, because they were still operating under the assumption that we would need to know how to type math code, because they couldn't assume that technology was going to run fast enough. Now the program I use to like do all our homeworks and stuff, I don't have to type the code because it's already done it for me. I go through the menus and select what I want. So, Michigan, that state up north that we don't normally type. So, Michigan, I'm starting to have some faith. I think some people in Michigan are wising up. Now, I really have nothing against the state. It's a beautiful state. We just have our athletic rival. My soon-to-be sister-in-law is from Michigan. But their population from the time of the 2000 census to the 2010 census went down enough to change the amount of representatives they get. So if you've been paying attention to everything we've been talking about the election process, how you get the number of representatives, which is also the number of electoral votes that we get, is directly based on your population. And really, your percent population compared to the whole nation. Either enough people left Michigan to lose a representative, or enough people were born other places that Michigan's percent went down that they lost a representative. What would this be as a percent decrease in representation? What is your percent decrease in that representation?
0.0.
So just by the way, do you hear how like you were trying to correct me, thinking that I was, so you got to hang on for a second and understand where we are going. Sometimes you don't see the whole picture. This is what we're talking about. I was not referencing the population in the table. I was getting there. Patience, young Padawan. You know,
Are you done talking? I'm never able to tell if somebody's done with the sentence.
listen for inflection. Try to, most sentences have like an up down, but also, I'm not coming to you, I'm using cards. I know you want to answer every single question. I'm aware of that. That's why teachers have to set up systems like cards. The reason I'm talking is to vamp time for other people that are actually calculating. Elena, what's my amount of decrease here?
I didn't get to calculate because I was listening to you talk about it.
It's okay. Just think through this with me. What's the amount of decrease? How many reps did they lose? Yeah, they lost 1. How many had they started out with? 15. So then I want to calculate what is 1/15th and then multiply it by 100 to get it into percent form. So, Mr. Long, do you have this?
Mr. Who?
Long. Noah Long. Meet your classmate. Hi.
What the percent form?
Give me a percent. Yeah, let's just jump right there.
6.66%.
I knew his last name.
And actually, would that round up?
Yeah.
Yeah.
But it's 6 repeating.
So, guys, I'm making the assumption that you are aware that there is a percent conversion happening in here. I'm okay with you not always writing the times 100 because we know that if there's a percent sign on the end, I had to do this time 100. Like, that's how it has to happen. So on your papers, if I see you jump right from the fraction to the percent, that's okay. I know what you did. That's kind of like 1/2 equals 0.5. You don't have to show the long division anymore. I know that you know how to get there. Just make sure that you don't forget to do that because I'm not always writing everything out. Now, one word that some mathematicians a little iffy on. Estimate. So when we estimate, this is like your everyday sort of mental math. You're not touching a calculator. You're making the numbers as easy as possible to work with. So if my percent change here needs to be estimated, what are you doing? I just said we don't touch calculators. Unless you're doing something else, we don't need it for any of
I
this.
already finished something.
Okay. So we want to estimate this. Absent today. Manasa, if we look at the change here, how much change has happened in this situation? A change of 9 if I'm talking like, actual values. And what was my start?
9 centimeters of 11 centimeters.
Now, if you actually memorized those division facts that we did, you might know this.
Ooh, I know this.
So let's look at that. But then we're going to look at the estimate. So if you remember 9/11ths, how did we deal with the 11ths, Dom?
I'm not really good with the 11ths, but I just memorized what 9/11ths was because.
Okay, what is it?
0.8181818181.
For 11ths, multiply your numerator by 9. For ninths, if my denominator was 9, multiply your numerator by 11. So this then becomes approximately, if we round, 82%. If we were estimating, though, 9/10 is a little bit difficult. 9/11 is a little bit difficult if I don't have a calculator and if I don't have those facts memorized. How could I make that easier? Jeremiah, you haven't talked much today.
10 is half of 20, and that's just 1 centimeter more than 10, so it's like it's a little bit above 50%.
Yeah, hold on. Reason back through that again. So we wanted to do percent change. We want to compare the change with the original. So because let's find this mistake. It's like identifying mistakes is really useful. You just said there's like a 50% growth, which by the way, notice they say not to scale. Don't trust what it looks like. So you said 11's close to 10, 10's like half of 20. We have like a 50% increase.
Above 50%.
Okay, but still, like, you're thinking about the 10 and the 20. Do I care about the number that I land?
No, less than that, because it grew less than 10.
So remember that we're comparing the change to the original. What was your change?
9 centimeters.
9. If I make the original easy to work with, instead of starting at 11, what could I say it started at? 10. This would give me approximately, which is why I'm using a squiggly equal sign, or you could I would just stick with like a squiggly equal sign to say approximately, that's 90%. Is 90% close to 82? Close enough. So since I know that I rounded my denominator down, I know that this value is actually going to be higher than it should be. I could also go the other way and make this 9/12, which would be approximately 3/4 or 75%. And I could know that my answer is going to land somewhere between these two values. And if I go right between these two values,
It's always 8% difference. Between the 11 and the 10.
yeah, this is right, not 12. This is right about at 82% if I go right between my two estimated values. So whether I round my denominator down and I get a slightly higher answer, or whether I round my denominator up and get a slightly lower answer, I'm just estimating, saying it's somewhere between these values. Jeremiah?
What is the squiggly equal sign mean?
You just said
Almost equal. So this is equals, but in this situation, this is what I was actually looking for, 82%, right? That's the real answer. This is an estimated answer. So when I do the squiggly equals, it's not my precise answer, it's an estimated answer. So where you're like, it's kind of means this, is what a squiggly equals means. Monica?
In like all problems, if you estimate down and then up, it was in the very middle of both of the numbers.
If you do the same going down or going up. So let's say this was like 13 and I round it to 12 and 15. So 12 I only went down 1, 15 I went up 2. So that then it would not land right between, but because I went down by 1 and up by 1, I did the same thing whichever way I estimated.
So if you do down by 1 and up by 1, you will always get the answer between those two?
You'll be very close. Won't be perfect, but be very, very close. Yeah. As long as you do the same thing with your estimates. I had already captured that. So try the percent change of our balloon, estimating as closely as possible.
But you wouldn't move your freaking.
Listen. Why'd you put 55 over 120?
Yes,
55.
approximating.
Well, hold on. This is if you used a calculator and broke the rules. Ozzy, real quick, what values did you use? Like, what division to estimate this, what'd you use? So that's why I had asked you, why were you using a calculator? When we estimate, I know, when we estimate, we don't use a calculator, which was what I told you twice and you still ignored me. That's why I kept asking you, why are you using a calculator? We're doing this math without calculators. If we used a calculator, would be what it was. But I could make my life easier, Jeremiah.
So I got 40. I did 45%. I did that because if you take away 5 from the 60, it's exactly half, so I just subtracted.
So if I estimate my percent change my amount change as 60, my original is still 120. So an estimated percent change here would be approximately 50% decrease.
And then I subtracted the 5 from the
We're going to pick up there tomorrow and talk about estimating without using calculators.
Are we really?
I don't know if people listen to me and stop using calculators, yeah.
Well, when you asked me, I was already on the other paper.